Hello student, I welcome you all in online lecture series. I am Dr. Ganesh Mogal, Assistant Professor, Department of Physics, T.Y.B.Sc. College, Nasik. Today we are going to discuss numericals of a bisection method. So let's begin. Uh, in previous lecture we discussed about error in computation. The error is a difference between the standard value or a true value and measure value. We also discuss significant figure. This is a figure which have some significance in a measurement, but it do not necessary to denote certainty. That is, the digit may be uncertain digit. In previous lecture, we also discussed about some uh, what is accuracy, what is precision. Friends, in this lecture, we have to see the numericals of a bisection method. After attending this lecture, the student will be able to find the root of a equation by using bisection method. Bisection method is a simple and reliable iterative method. This method is also known as a half interval method. Okay. In this method, we find okay f of x0, f of x1. If f of x0 and f of x1 have opposite sign and f of x0, f of x1 is less than 0, then we can say that the root is lies in between x0 and x1. Okay, simply f of x it is equal to 0 at x is equal to x0 and x is equal to x1. X0 and x1 are the root of f of x. Here the f of x have a negative value. F of x have negative value when x is equal to x0. F of x have positive value when x is equal to x1. And then we can say that the root is lies in between x0 and x1. Then we find x2, or we can consider x2 is a midpoint of x0 and x1. Then we can say that x2 is equal to x0 plus x1 divided by 2. Then we again find f of x0 and f of x2. If f of x0 and f of x2 have opposite sign, then we can say that the root is lies in between x0 and x2. And after that we find x3. x3 it is equal to x0 plus x2 divided by 2. So here simply this represent the function, okay, function fx. This represent function fx. Okay, here x, this represent x0 and here is x1. And if f of x0 and f of x2 have negative sign, then we can say that root is lies in between x0 and x2. Root is lies in between x0 and x2. Then we can find x3. Okay, and this x3 it is equal to x0 plus x2 divided by 2. Okay, this process is carried out. Okay, first we find here the root in between x0 and x2. After that we find midpoint, that is x3, and the root root. Now again we check f of x3, f of x3, or we find f of x3, f of x2, f of x2, and f of x0. If this f of x3 and f of x2 both have the opposite sign, okay, that is, if f of x3 have positive sign, f of x2 have negative sign, then we can say that root is lies in between x2 and x3, and this process is carried out. Now we have to see the numericals of this bisection method here. So consider the here function is given, and that function fx is equal to x cube minus minus 1.8 x square minus 10x plus 17, it is equal to 0. And using bisection method, we have to find the root of this equation at the end of a fifth iteration. At the end of fifth iteration. So the function is fx, and this fx, it is equal to x cube minus 1.8 x square minus 10x plus 17, it is equal to 0. This is a function. Now we find the value at f of 0, or we can say that f of x0. Value of x is considered as a 0, so it became 0. This term also became 0. Then the third term also became 0 plus 17. Okay, so we get it is equal to 17. Okay, now we find f of 1, that is, put value of x is equal to 1. So 1 cube minus 1.8 into 1 square minus 10 into 1 plus 17. Okay, and it is equal to 6.2. Okay, now we find uh, the value of this function when x is equal to 2. This indicates that 2 cube minus 1.8 into 2 square minus 10 into 2 plus 17, and it is equal to minus 2.2. Here, this is f of x1, or f of 1 is positive, f of 2 is negative. It indicates that root is lies in between 1 and 2. Root lies in between 1 and 2, so that we can find value of x2. It is equal to, that is, half interval x0 plus x1 divided by 2. Here x0, this is considered as x0, this is considered as x1. So 1 plus 2 divided by 2. So value of value of x2 is a 3 upon 2, that is 1.5. Okay, 1.5. Now we have to find f of x2. F of x2, and it can be written as 1.5 bracket cube minus 1.8 1.8 into 1.5 brackets square minus 10 into 1.5 plus 17, it is equal to plus 17. Okay, and so the value of f of x2 is, after solving this, we get 1.325. 1.325. Now f of x2 f of x2 into f of, that is or simply we say that f of 2 into f of 1.5 1.5, or we can say that f of x1 into f of x2, it is less than 0. Then we get the root lies in between x1. This is x1. Okay, this is considered as a x1. This is considered as x2. The root is lies in between x1 and x2. Now replace the x0 and x2 by 1.5 and 2. 1.5 and 2, so that our second iteration we get second iteration, that is uh, x0 is considered as 1.5 and x1 is considered as 2, and therefore we get x2, it is equal to 1.5 plus 2 divided by 2, and this value is 1.75. 1.75. Now find f of 1.5, and we know that f of 1.5 is 1.325. Okay, here f of 1.5 is 1.325. F of 2, it is equal to minus 2.2. Okay, f of 1.75. Okay, f of 1.75, that is x2 is equal to 1.5 plus 2 divided by 2, so we get 1.75, and its value is, that is 1.75 cube minus 1.8 into 1.75 its square minus 10 into 1.75 plus 17. Okay, and after solving this we get it is equal to minus 0.653125 after solving this. Okay, now this is negative. Okay, this is negative. Okay, and here for 1.5 this is a positive, and therefore we can say that root is a lies in between 1.5 and 1.75. Root is a lies in between 1.5 and 1.75. Now here replace x1 by x2. Okay, and that is we can say that here x0 is considered as 1.5 and x1 is considered as a 1.75. Okay, and x2, now this is the second iteration. Okay, this is the second iteration, this is the first iteration, this is the second iteration, now third iteration. Okay, iteration third. Okay, iteration third, here x2 it is equal to x2 is equal to x0 plus x1 divided by 2, but here x0 is considered as a 1.5, x1 is considered as a 1.75 divided by 2, and we get x2 is equal to 1.625. 1.625. Now find here we know that f of x0, that is f of value of function at when x0 is considered as a 1.5, it is a 1.325. F of x1, that is value of the function when x1 is a 1.75, it is minus 0.653125. Okay, now f of x2, x2 is now 1.625. Okay, f of x2, that is a function f of 1.625, so it is equal to 1.625 its cube, okay, minus 1.8 into 1.625 its square minus 10 into 1.625, okay, plus 17. And when we calculate this, we get f of x2, it is 0.287891. Okay, now again f of 1.75 into f of 1.625, it is less than 0. Here the value of this function f of 1.75 is negative and f of 1.625 is a positive, and therefore its multiplication is less than 0, and therefore we can say that root is lies in between 1.75 and 1.625. Here now replace x0 by 1.75 and x1 by 1.625. Okay, so iteration 4 very simple. Iteration 4, here this is considered as x0 and this is considered as x1, and therefore x2 is equal to x0 plus x1, that is 1.75 plus 1.625 divided by 2. Okay, divided by 2, and we get 1.6875 midpoint. Okay, 1.6825. Now find f of x0. F of x0, it is we can consider as a is 1.75. Okay, 1.75, its value is minus 0.653125. Okay, f of x1, it when we put a value of x1 is, or x1 is considered as a 1.625, and its value is 0.287891, and f of x2, that is here, this is now considered as x2. Okay, and we get 1.626875, it's a cube, minus 1.8 into 1.6875, its square, minus 10 into 1.6875 plus 17. And when we calculate this, or when we find this, we get the value of this is minus 0.195361. Okay, here again this value is a negative, this value is negative. Okay, 1.625. Okay, 1.625, here this value is a positive. This value is a positive and this value is a negative. And therefore, we can say that this is a consider as a x0, this is a consider as x1, okay, that is 1.625 is a consider as x0 and 1.6875 is a consider as x1. Here again we find f of x2 is negative, okay. F of 1.625, its value is a positive and f of 1.6875, its value is a negative and therefore its multiplication is less than 0, and therefore we can say that a root is lies in between 1.625 and 1.6875. Here this is a consider as a x0 and this is a consider as a x1, and therefore we again find iteration 5. So iteration 5. Here x0 is considered as a 1.625 and x1 is considered as a 1.6875, and therefore x2 it is equal to x0 plus x1 divided by 2, that is 1.625 plus 1.6875 divided by 2, and value of x2 we get its value is 1.6565. Now here again f of x2, f of x2, that is f of 1.6565 and its value is 0.04317. Okay, f of x1, okay, f of x1, or we can say that f of x0, okay, because we consider x0 as a 1.625, so f of x0 that is 1.625, it is equal to 0.287891, okay, and f of x1 we consider x1 as a 1.6875, so f of 1.6875, it is equal to minus 0.195361. Okay, now this is a positive x2, f of x2 is a positive and f of x1 is a negative, and therefore we can say that the root is lies in between x2 and x1. Root is lies in between x2 and x1. F of x1 into f of x2 is less than 0, and hence we can say that the after fifth iteration approximate root of x1 and x2, so the root of this x1 and x2, it is equal to 1.65625 plus 1.6875 divided by 2, and we get the approximate root after fifth iteration 1.7 1.671875. So this is the approximate root after fifth iteration. Okay. Now, bisection method is used to determine the root of equation. First, the function is given. Then find f of x0. That is, put value of x0 x as a 0. Find f of x1. That is, put value of x as a 1. Then find f of x2. That is, put value of x is 2. If we obtain two value, one is a positive and other is a negative, and then we can say that the root is lies in between that two value. Okay. Then find x2, that is x0 plus x1 divided by 2. Okay. Solve it. Then again find f of x2. Okay. We know that f of x0, f of x1, f of x2. Then we can say that there may be some one positive and one negative value, and we can say that the root is lies in between that two value. Okay. Replace x0 by x1, then x1 by x2, and this process is carried out up to a particular iteration. Okay, and we get approximate root after a particular iteration. Now you have some assignment. Using bisection method, find a root of equation x cube minus 2x minus 10 is equal to 0. Send this assignment on Google Classroom. After this lecture, or in next lecture, we have to see algorithm, flowchart, and program to find the root of equation using bisection method. Thank you.